Hi everybody, my name is Ian McLaughlin, and I have a PhD in neuroscience from the University of Pennsylvania, and I hope you're all doing well. It's kind of a surreal day because I've been using this platform, Periscope, for years, almost the majority of my PhD, to talk, and gave me the privilege of speaking with people all over the world, truly all over the world, and it made me a better person, made me a much better scientist. And I'm just so grateful that you've all even been interested in chatting with me, let alone chatting about neuroscience. So now, if you want to stay in touch, I've been using two other platforms. One is YouTube, so youtube.com/anthropoid, where I talk about a specific topic and then, hopefully engage some live interaction. And then haps.tv, happs.tv. Links to both in my profile on Periscope. I've enjoyed you for years. You know what? I bet I've enjoyed chatting with you more. It's so strange. It's been so long that it's like sort of just a part of of how I think about learning new things and sharing the things that I learn with people. It just adds a level of sort of I don't know. It just makes it more human, I think, just being able to share. Yeah, me too, Patty. All right, so once again, if you want to stay in touch, youtube.com/anthropoid, and that's YouTube, and then haps.tv. It's another platform, live streaming platform, new one. All the other scientists that have been active over the past few years are over there. And so links to both in my profile. All right, is it possible to get a brain transplant? Great topic. And it's one of those topics that's come up, pretty much every single year that I've talked about neuroscience. But a couple years ago, there was the prospect that it might actually happen, that there might actually be a brain transplant, or at least an attempt to transplant a brain. And this was announced by an ambitious Italian neurosurgeon named Sergio Canavero. And so he made this claim that I will be the first neurosurgeon to transplant a brain. Everybody was skeptical, but hey, it's gonna happen at some point, right? Or at least somebody's gonna try it at some point. And so he conducted some arguably somewhat macabre experiments where he would transplant the heads of other animal models and attach a second head to certain animals. Pretty kind of grotesque, kind of tough to look at, but they were reasonably successful. However, none of the animals with whom he worked would survive for very long. And that was intentional. It was part of the research, was to not allow them to live for particularly long. Okay, whatever. Let's we'll wait and see, right? Part of the reason for why I became so skeptical, like almost right off the bat, was reading his explanation for why he was going to be able to pull this off, right? And he called it the Gemini protocol or something like that, Gemini method, where basically it's just like three things. It's like he argued that he could just do a really precise cut along, the spinal cord, and so he wouldn't crush any of the projections. Because of course, if you're going to have a successful brain transplant / head transplant, it would probably be a head transplant, then you're going to need the central nervous system to reunite, to reconnect. So really, really precise cut. And then the use of what he called fusogens. And you might think, oh, fusogens, that might be like an exciting mixture of stem cells and all kinds of interesting solvents and molecules, hormones and stuff. And no, it was just like solvents. It was just solvents. I think one of them was polyethylene glycol, made famous most recently due to its inclusion in certain therapeutics, certain medications that are changing the world right now. So he made this claim. About a year after he made that claim, maybe 2 years afterwards, he announces a partnership with a group in China, a whole team of surgeons in China, and they claimed they were going to do it. And they had, not only that did they make this announcement of this partnership, but they also claimed that they had volunteers who were willing to partake. And so they then announced they've successfully done a head transplant. but it was between cadavers. So meaning people who had already passed away. And so I don't know about you, but if I ever go through a head transplant, I want to make sure that it's performed before I pass away, if the goal is to actually have a head transplant. And it's been, I think that was in 2018, if I remember correctly. And it's been a couple years and we haven't heard of any success. So I do suspect that the skeptics won the day on that one. And it's unlikely that, at least as of today, there will ever be a head transplant, let alone a brain transplant. However, let's step back. How old am I? That was one of the first questions I ever got. How old do you think I am? That was always the question that I would ask, and I suspect I'll be less amused by your answers now than I was back then. But anyways, so let's step back. Why is it so difficult to do a head transplant? Yeah, over 21, Elizabeth. That's true. Well, the brain is the most complex organ in the human body, arguably the most complex organ in the universe of which we are aware. And so a lot of things are going to have to go right. It's a lot more difficult than, for example, a heart transplant. Extraordinarily challenging and marvelous capability that modern medicine has. But the heart is effectively a muscle that is a pump, right? And so you just have to make sure all the pipes are connected in the right places, and bingo bongo, you have a new heart. Same goes for all kinds of organ transplants, right? It's kind of remarkable. What's interesting is that the vast majority of organs, evidently, you can do an organ transplant between a male and a female. They're similar enough that there's no big problem there. And a recent study came out that evaluates whether or not there truly are significant differences between the brains of men and women. People identifying themselves as men and women, and we can talk about that study if you like. It has some interesting results, and I would argue that it's the most comprehensive. It's a meta-analysis, really, so it's a study of studies, but we can talk about that if you'd like. Anyways, so the brain is more complicated than any other organ, right? So it's going to be more difficult, but just like all the other organs, the brain does obey the laws of physics, right? It is a physical thing. It's a biological, organ that obeys the laws of physics. And you can manipulate the laws of physics so long as you're not trying to break them, right? And so if there's no magical substance, no metaphysical, no non-physical, aspect of the human brain, then why couldn't we do a head transplant or a brain transplant, right? And so you ask me, is it possible to do a brain transplant? Theoretically, yes, it is possible from my perspective, just because, once again, the brain, and therefore the consciousness that it generates, obeys the laws of physics, right? Just like all the other organs. However, it's not going to be happening for a very long time. It almost certainly wouldn't be an actual brain transplant. It would probably be a head transplant. And so I wouldn't hold my breath. I wouldn't recommend you hold your breath for the prospect of having a head transplant. But theoretically, if that was in a science fiction book, that wouldn't be the craziest fiction in that science fiction book. Okay, so Deanna C. Hooper is in here. She is a theoretical physicist. She studies dark matter, dark energy, the cosmos, the birth of the universe, the origins of the universe, some of the coolest questions that I think all of us have, but can never answer because either we don't know enough, but she does know enough. So you can check her out. She's been on Periscope for quite a long time, and now she has joined along with me. We have joined this new live streaming platform, haps.tv. So you can check us both out. You can ask her the hard questions. I always send people with the harder questions over to Deanna. I invite you to check it out. I have a link in my profile page on Periscope if you'd like to join. And Lisa is here too. Lisa also is on haps.tv. You can ask her really complicated questions. She'll give you probably some very insightful answers. But she doesn't tend to talk too much about neuroscience and the cosmos. But I bet you could convince her to. So check out Lisa as well. Over 21, yeah. So where do you go after Periscope finishing? Yeah, Juliet. I'm grateful that people are asking. And so I mentioned haps.tv. That is the main place where I've been exploring, continuing live stream stuff, but then also youtube.com/anthropoid, where I tend to just focus on a specific topic, at least for the beginning, 15, 20 minutes. Like, I'll give you some examples. Recently I talked about Neuralink and Elon Musk. his new company. And I've talked about the problems with the way that we're confronting addiction. I've talked about a novel potential cure for tinnitus, not tinnitus, tinnitus. People call it tinnitus, mispronunciation. And the cool thing about that cure, that potential cure, treatment, let's call it a treatment, is that it's non-invasive. You don't have to have any kind of surgery, any kind of injections. It's basically just a set of Bluetooth headphones and then a kind of interesting device that you wear on your tongue. And basically what it does is it distracts you from your tinnitus. But potentially it pretty much works. Or at least they have solid evidence that it does. I've talked about psilocybin, magic mushrooms, and depression, and novel treatments for depression in general, and as well as microdosing, schizophrenia, the relationship between science and politics. And someone, yeah, I talked about a case study of somebody who snorted 550 times the normal dose of LSD. Pretty insane. I've talked about why it is that we hallucinate. Also, how it is, what happens in our body, what happens in our brain when we trust somebody. And so, a bunch of topics like that. Potential cures for Parkinson's disease, and on and on. Alzheimer's disease, of course. How parents' lives influence the brains of their children, color perception, the Dunning-Kruger effect, which is obviously a very popular topic on the internet, whether or not the Dunning-Kruger effect even is real. So go check it out, youtube.com/anthropoid, link in my profile on Periscope. Is it because it's not ethical or not technical? So I assume what you mean is IT supremacy. I assume you're referring to the head transplant topic. The ethics, that's a different conversation. And I think it's a very interesting and important conversation regarding, to whom would such a service be available, right? It could be particularly useful for folks whose the health of their brain is totally, intact. They're intact. They're fine. No disease or disorder of the brain, but their body, for one reason or another, is afflicted. So that, that could change their lives. And theoretically you could have donors, right, who would be willing to donate their entire body. But yeah, I mean, the ethical conversation is distinct, right? Although I think we do have some precedent for the ethical conversations that we have about these kinds of transplant surgeries, right? We do have organ transplants. They regularly occur. I also talked about a new potential treatment that would mitigate the need for liver transplants among I think like a third of adults who require a liver transplant tends to have to do with some kind of malfunction of the bile ducts. But then 70% of liver transplants in children. So anyway, so we've talked about transplants, right? We do transplants, and society is okay with them. But there is something different about a head transplant or a brain transplant, right? Which I believe, given the fact that I think most people have like a sort of a unique reaction to the prospect of a head transplant, I think that reveals that we all kind of agree that there's something special about the brain. Okay, so Issa Beta Bug is here. And so it is the technical limitations today that are preventing it from happening, not ethical limitations. Though I suspect, just like CRISPR, right? We didn't have something as useful, as precise a tool as CRISPR to literally modify the human genome, potentially for the rest of time. Right? Like I could, for example, use CRISPR-Cas9, again, it's a technique to modify the genome of my gametes, right, of my sperm or my wife's eggs, and that would mean that our children, should we have one, or should we have some with those modified gametes, sperm and eggs, that our gene pool is modified for all eternity, potentially therefore influencing those of other humans, right? Because they reproduce. So, that's an ethical quandary that we didn't really have to confront before the invention of CRISPR-Cas9. I think we're going to be in the same boat when it comes to, the prospect of a head transplant. And hey, people are trying to do it. And once again, the only thing preventing us from accomplishing this is a deficit of knowledge and a deficit of technique and technology, but we'll get there. So Issa Beta Bug is here. Isabel Betancourt, she is an entomologist. And she has also been using Periscope for quite a long time. She's arguably one of the few remaining scientists who has sustained, interactions with folks outside of our disciplines. One of those of us who are privileged enough to get to talk about the things we love with people who are interested. And so she also has migrated, well, not migrated, but she's also been using happs.tv, HAPPS.tv. You can find her there, along with Deanna C. Hooper, a theoretical physicist, and me. So you can go check it out. I have a link in my profile. I'm sure that they have links in their profiles as well. And so come and join us, and let's keep our conversations going, and let's keep growing together. Okay, so yeah, Deanna, great periscopers. I agree. Is being gay a brain syndrome? So when you say, okay, let's break that down a little bit. So, is homosexuality, is it a syndrome? When you use the term syndrome, I think that implies that there's something unhealthy about it, or something biologically aberrant about it. And that's just not the case. It's not only not unusual among humans and primates in general, but it's not unusual among the entire kingdom of Animalia, right? All animals, essentially. There's instances of it regularly. So it's not like it's this quirk of human behavior. It's part of being an animal, right? However, does homosexuality arise from the brain? In large part, yes. Just like being heterosexual does, right? Sexual attraction, libido, the desire to, affection. All of these things arise from the brain. And so just as much as, I love my wife, I'm heterosexual, somebody who, if I were to love my husband, the same very similar brain regions would be involved. Human attraction is extraordinarily complicated. Everything humans do is extraordinarily complicated, and so it's inevitably going to involve. It's not like there's going to be one brain region that regulates heterosexuality versus homosexuality versus everything in between, right? It's a collaboration of brain regions, but then also life experiences, and so is homosexuality a brain syndrome? I wouldn't call it that. I'd say homosexuality is a byproduct of brain activity, to a large degree, and in collaboration with the environment. Gonna miss your informative scopes. Well, I am certainly gonna miss using this platform to have conversations with people all over the world. I mean, I've made some really wonderful friends, including two wonderful people here, Issa Betabug and Deanna C. Hooper. But I've also had the privilege of learning from people all over the world, having conversations with people in Indonesia, in Saudi Arabia, in the United Kingdom, all throughout Europe, all throughout the United States as well. Some great friends, people whom I'd never meet were it not for this platform and a shared interest in science, in neuroscience. So if you want to sustain our conversations, if you ever want to correct me when I get something wrong, which I hope you will if I do, check out I have a YouTube channel, youtube.com/anthropoid, and I have been using a platform called happs.tv, moved to YouTube Live. Yeah, so I do that, but happs.tv, it's a new live streaming community, and frankly it is better than Periscope in many ways. The thing it lacks is just the comparable user base size, right? It's tough to compete with Twitter and Periscope, right? But it's a new platform, and it's better in a couple of ways. Happs.tv is a new platform. It's better in a couple of ways. One is just the tools, the production tools that they give us for free, right? I mean, I can do things with that platform. I can play videos for you, which I did yesterday, actually. I can, show you pictures. I can actually bring you closer to the science that we're discussing. But also the philosophies of the people who run the company are different, right? These are people who have backgrounds in journalism, not, the sort of more typical Silicon Valley, sort of startup culture. And they have a great philosophy when it comes to misinformation, pseudoscience, and it is also a wonderful community, right? I've yet to engage somebody there who was just interested in making me suffer, which I had to get used to using this platform. I miss being able to super hard. Yeah. Well, so Happs does have integrated support features, but like that. But it, I think there are things about Periscope that they just happen to get right. I think the interface is the best of any other platform I've ever used. I've seen a lot of live streaming platforms come and go over the past few years, a lot. And most of them will have some kind of gimmick, like an integrated, cryptocurrency or blockchain token or something like that. But they're all essentially the same, and they're all just, chaotic. So Periscope is simple, and I think it's just easier to use for more people. It made it easier for people who otherwise wouldn't engage technology in this level to engage it. So I am also going to miss it, Elizabeth. All right, it looks like we are connected. Gary, the banker. Where are you calling from, and where are you calling from? You want an ice cream truck?
Hello there.
I'm not. Oh, looks like we. Sorry about that. Feel free to call back in. I thought you were just playing music. Anything? Okay, so, all right. Would it be possible to put human brain into an ape? Would it reject it immediately? That's fun. Now we're getting. This is the kind of conversation I like. So first of all, could you do that? No. The ape body would immediately reject it. Apes have immune systems. Humans have immune systems, and it's already it's difficult to find a compatible organ donor. Like, for example, if you need a heart transplant or a liver transplant, a lot of things have to match up between you and the donor for your own immune system to not attack it, and attack it as though it's a pathogen, right? That's invading your body. Same thing would happen in an ape. But theoretically, if you wanted to do it, if you really, really wanted to do it, I could imagine genetically altering the immune system of an ape to render it incapable of mounting. And that's called host graft rejection, right? I could imagine you trying to do that, but I mean, you would have to be really motivated to make an ape with a human brain. But I'd like to see it. That would be fun. Okay, yes, I did go to Penn, and it looks like somebody's calling in. All right, there's some signs of trollery. We lost him. Okay, so what is your view on subliminal mind programming of the human brain? One beloved. So, so when you say programming, I mean, like, does it exist? Yes. That is essentially the entire, field of marketing is devoted to trying to elicit responses from parts of your consciousness over which you have little control, right? Your sort of your impulses, your urges, right? The things that sort of operating under the hood, about which you are not consciously aware, or you can't even consciously really alter, right? Like things like sexual attraction, right? That is a very primitive component of human consciousness, and obviously it's marketing tapped very widely. I think one of the most successful strategies in marketing is to manipulate that. But I do think also that when people talk about like subliminal, suggestion and these types of things, that there's also just a ton of pseudoscience. There's a ton of nonsense. But does it exist? Certainly. Are you going to get me too'd? I'm not sure what you mean. Oh, me too'd. Am I going to get me too'd? I know. I don't see why. No. I'm, married. Okay. Hello from Dubai. Very cool. I went to Dubai for, I think for about 2 weeks. It's a very interesting place. I don't really know if there's any place like it. It was very interesting. And I was fortunate to be with people who are from Dubai. So, but I think the coolest part of that trip was we visited what's called the Empty Quarter. So I went with a school group, and we went to an area called the Empty Quarter, which I believe is actually part of Saudi Arabia. But it's when you look at the images and videos of just endless desert, that's the Empty Quarter. It is a surreal landscape. It looks a lot like the pictures we're getting back from Mars right now. Like it's just. And like the things that I just happened to find were crazy. Like I found a completely, I don't know what to call it, but just like an exposed, antelope skull or something like that. A skull with like horns. It was like buried in the sand. Just crazy stuff. Not crazy, but cool. Yeah, so that was a lot of fun. I saw doctors discussing long-term effects of COVID on the brain. Have you examined this? So, Jarugambian, Jaru, sorry, my tongue is not nimble enough for your handle, but yeah. So there is certainly concern of long, lingering ramifications of being infected with SARS coronavirus 2, the virus that causes COVID-19, on multiple parts of the body. Not just the brain, but certainly including the brain. And and this is something I've talked about a fair bit on YouTube as well, youtube.com/anthropoid, brainologist man. There have been enough studies that have come out. So initially, right, when we all sort of were under the assumption that this was essentially just a standard coronavirus, like a respiratory virus that, just really infects your respiratory system, and then, it could be pretty rough, but you get over it. Like the other coronaviruses that are essentially just circulating seasonally. But it turned out that there are many things that are unique about this virus. And one of the earlier indications that there might be some nervous system component to COVID-19, to the virus, was that I can't believe I'm blocking somebody on the last day on Periscope. That's so funny. I like never block people. But anyways, were some interesting reports that people would show up at hospitals without any symptoms, any of the standard symptoms of COVID-19. They weren't coughing, they didn't have fevers, none of that kind of stuff. But they were showing up with like confusion, right? Or having a stroke, or having what appear to be neurological symptoms. They would show up to the hospital for those, no indication that they had COVID-19. And then their physicians would evaluate them, and this was, as COVID-19 was really, beginning to rise in the United States. The earlier reports were some early reports out of China, but the earliest reports that I saw were out of Italy and then France. And it got to the point in Italy where a hospital set up a hospital ward dedicated specifically to COVID-19 patients with neurological symptoms. This was reported in Italy. This was reported in France, and then it was reported in the United States. The patients showing up with primarily neurological symptoms. And so, a lot of people were catching this virus, and people, will have neurological symptoms, right? There's like sort of a standard frequency at which that occurs. So, it would be unsurprising that like somebody would have neurological symptoms and then also happen to have the virus, and there wouldn't necessarily be an interaction. However, as time went on, the sort of like probably the most widely appreciated neurological symptom that is now one of the standard things that we care about, surveil, is anosmia, or the loss of the ability to smell, and potentially also a deficit in taste. So that became interesting, right? And I had a conversation with my former mentor, who runs a lab at the University of Pennsylvania, and I was like, hey, what do you think about this? Like, do you think that there's a neurological component to it? And she was in the same boat as in which we all were, right? Where we don't know, but I'm certainly giving it more credence now after all these reports. Months later, as more scientific disciplines engaged COVID-19, different labs basically developed several lines of evidence suggesting that it does indeed. It's certainly capable of infecting neurons. Okay, not only that. The spike protein, or part of the spike protein, which is, the very infamous component of the viral particle these days. We all know about it. It's the thing about the viral particle that enables it to attach to cells and then eventually be infected, right? That protein seems to be capable of crossing the blood-brain barrier. And by the way, just that alone would theoretically potentially could induce neurological symptoms. Just the presence of that foreign protein, not even just the whole viral particle. But so we know that the virus can infect neurons. We know that part of the virus at least can get into the brain. And then now more recent studies have been done using something called organoids, brain organoids, which are basically sort of like little mini, they're sort of like bonsai brains. They're sort of like mini little brains. It's a way that you can study neurons and brain cells in a condition that more closely resembles that of, their natural residence, which is in the brain, right? Several studies now have explored what SARS coronavirus 2, again, the virus that causes COVID-19, what it can do when these organoids, these little mini brains, are exposed to it. And it is at the point where I think there's enough evidence to suspect that in some cases, for some reason, and we don't know what that reason is. SARS coronavirus 2 is capable of gaining access, or at least a part of it is capable of directly influencing the human brain, certainly the nervous system. Now, I say suspect. We don't know that for sure, right? However, and it's also important to recognize that you can have neurological symptoms without having a virus directly influence the brain, right? You can have just, perhaps you've heard of this term cytokine storm, where your immune system is just freaking out. It's going overboard. It's instead of like attacking, the specific viral particles or, of course, the cells that are infected by the viral particles, it just carpet bombs the brain or carpet bombs the body, right? That's sort of like what a cytokine storm is, just totally non-selective, and it's just wreaking havoc on the body. That can generate some neurological symptoms, in and of itself, irrespective of what the virus is doing in the nervous system. So, what do we know for sure? We know those lines of evidence that I described. Good reason in my mind to suspect that there could be a direct influence on the brain of the viral particle itself. And we can recognize and appreciate that it doesn't need to directly affect the brain to induce long-lasting consequences for the brain. So, we'll keep our eyes peeled. It's a difficult kind of thing to prove conclusively, right? Because, ideally you'd want to study a human's brain, right? And that could be tough. But yeah, I mean, and that is just one of a longer list of what appear to be long-lasting consequences of COVID-19 in some people, the long haul, syndrome, where people have symptoms for months and months and months. There's some people who've had symptoms from the very beginning of the first wave in the United States. And so, yeah, this is not a thing you want to catch. This is, it is also true that quite a few people are fine. They don't even know that they were exposed, right? But we have no way of knowing whether or not you are one of those people. So you want to avoid it. You want to get vaccinated and avoid it. Okay, can the brain heal from childhood trauma? Very interesting topic. In fact, there was a study that just came out. I was considering specifically talking about it. So there was a study that came out of Montreal that basically explored the ramifications of harsh parenting, right? So this is parenting that's a little bit more martial, right? Maybe physical spankings, these types of things, but also just, getting angry regularly at children, the parents getting angry regularly at children. And basically what they found were anatomical ramifications of that, where people will have, long-lasting differences in literally the sizes of brain structures. And you probably don't have to think, guess too wildly to speculate which group of children, the ones who were, harsh parented versus those who weren't, which one of those two had the smaller brains. They were the recipients of the harsh parenting. And so there, and this is one of many studies now that have shown that childhood trauma, certainly, can have very long-lasting ramifications. I'll give you one example that doesn't have to do with neuroanatomy. Statistics show that folks who endure one adverse childhood experience, and that can be physical abuse, sexual abuse, it can be just any form of trauma. It doesn't have to be harsh parenting or something like that. They are significantly more likely to experience a bout of psychosis in adulthood. And if there are multiple adverse childhood experiences, again, some form of trauma, the frequency or the likelihood increases of experiencing psychosis into adulthood. That's just one example. I mean, there are, and there's plenty of evidence that serious child abuse, like physical, sexual abuse, are linked to, very closely linked to increased likelihood of developing depression, anxiety-associated conditions. When it comes to addiction, there was a study that was done by actually a friend of mine who was on my same fellowship at the University of Pennsylvania. He was studying humans. He was studying humans with addiction who had come into a clinic for treatment. And I'm, don't quote me on the specific numbers, but I'm very, very close in the ballpark. Something like over 80% of the people going into a clinic for the treatment of addiction, and this is, addiction to one or multiple drugs, had some form of childhood trauma. And so, this is the consequences of this kind of these types of experiences are significant and long lasting. However, what you were interested in was, can you heal from these forms of trauma? And, of course, it depends on how you're defining heal, right? Those long-lasting consequences, they exist. But can you heal? Can you have a high quality of life? Can you live as though that they didn't even happen? Yes. But, it's prudent in that case, if you are one of those folks, to seek out, clinical, counseling, right? Seek out a psychiatrist, a psychologist, get therapy. Probably way more people than get therapy should be getting therapy, right? And it's one of those things that doesn't hurt, right? Now I understand it's expensive, and not everybody's in a position to be able to afford it, which is a huge problem. But that is the way to heal, right, from childhood trauma. And then, of course, if you are self-medicating, right, which again, huge proportion of people with addiction, are essentially self-medicating for some childhood trauma. If you are suffering from one of these conditions, from addiction or from depression or from generalized anxiety disorder, then it's particularly critical to get help, to get clinical help. People have devoted their lives to helping people in those positions, heal. And that healing, when I say heal, like, I'm not just talking about just, not being free from addiction or free from, depression or anxiety disorders, right? That treatment, the reason it's effective is that there are physical changes that occur in the brain as a result. And so the reason that therapy is effective is that it also is associated with physical changes in the brain. And so, so the answer is yes, you can heal. But I would recommend, from the perspective of a scientist, I would recommend that you make sure you get the kind of assistance that is available to you, to ensure that you do heal. Okay, so great topic. So glad you're both on HAPS. Me too, Lisa, and we're glad you're there. Oh, thank you very much, Isa, for sharing the link. Yeah, so Isa shared the link to get to haps.tv. I also have a link in my profile. Also, you have a YouTube channel, youtube.com/anthropoid, where I tend to talk about a specific topic for about 20 or so minutes. That's probably going to change. I'm probably going to really focus on that now for at least the near future. So that's youtube.com/anthropoid. There's a link to that in my profile on Periscope. Yeah, me too. Oh, and HAPS also does have great moderation tools. Yeah, which are essentially absent on Periscope. Do you think the COVID vaccine is dangerous? The short answer is no. In fact, what is one of the many things that is remarkable about these vaccines, and I'm going to talk about one really, really amazing potential application of these vaccines once we're on the other side of COVID, which, by the way, the only way that we're going to get to the other side of COVID-19 is by using these vaccines. But something that's remarkable about them is that they are so safe that there's like remarkably few adverse reactions. I mean, like far lower than a level that would be tolerable, right? Like, I would be okay if levels of adverse reactions were higher than they are. So why are you ignoring me? I'm sorry about that. I think you brought up this topic, did you not? But you're talking about car accident or child abuse? Child abuse, but also physical trauma. A car accident would fall under that category when I was talking about, healing from childhood traumatic experiences. Okay, so these vaccines are very, very safe, okay? I've gotten vaccinated. I was lucky enough to be able to get, surplus vaccines at a place where everybody who had appointments had them fulfilled, and they had excess vaccines, and they're like essentially regulatorily like required to use them, and I was fortunate to be able to wait around and get one. My wife got one as well, for the same reason. And I can talk about my reactions. My arm was a little bit sore. I got the Moderna vaccine. My arm was a little bit sore, which is the most common reaction, particularly among people in my age group. Oh, I never answered the question of how old I am. I think I'm 33 now. So, that I'm not super young, but I'm also not really in the older demographics. But the most frequent adverse reaction, which is barely anything, is just, a sore shoulder. And that was gone basically in about a day and a half, 2 days. And that was it. There was a day where I had a headache, but it was several days after I was vaccinated, and I don't think it was connected. And by the way, I took a fraction of a dose of a non-steroidal I think it was ibuprofen, and totally gone. And they will counsel you when you get your vaccine, right? So, those are the two mRNA vaccines, which are remarkably cool. And 1 second, I'll talk about probably the coolest potential application of these mRNA vaccines. But that's also true for the J&J vaccine, the Johnson & Johnson vaccine, and also true for the Oxford AstraZeneca vaccine. I know that there was some pretty reckless reactions in some European countries to reports of some reactions to the Oxford AstraZeneca vaccine, which were never verified, are not verified, and don't seem to be true. And I think that there will be a measurable effect of that decision to do that, or their decision to how to respond to that. The Oxford AstraZeneca vaccine and the Johnson & Johnson vaccine are really quite similar. They're both modified adenoviruses. The Sputnik 5 vaccine, I think is what they call it, that's the Russian vaccine, is actually a combination of 2 modified adenoviruses, which is really quite interesting. That was one of the questions I had early on. So I made viruses as a part of my research. And I had to endure immunology classes as a part of my grad school program. And so, and I worked with adeno-associated viruses. They're really a different kind of virus, but the same types of principles apply to a modified, adenovirus, which is, they're just sequences, right? It's just a virus. And so one of my questions was, and I'm wondering about this when it comes to the mRNA vaccines as well, is it superior to, instead of having 2 shots of the same modified adenovirus, which is what the Oxford AstraZeneca virus, I like to call it Oxaz, just because those are 2 big words and it takes time to say them, but Oxaz. Oxford AstraZeneca is just 2 doses of the same modified adenovirus, whereas the Sputnik 5 strategy is 2 slightly different adenoviruses. Which, there's a lot of interesting potential differences in how effective they may or may not be. But to be clear, the Oxford AstraZeneca virus is very effective, very effective. Same goes for the Johnson & Johnson vaccine. So yes, are they safe? They're definitely safe. And not only that, even if they were a little bit less safe, right? Even if people had more substantial immune reactions. And by the way, if you do have a reaction, if you have headaches, if you have chills, that is a good sign. That means that your immune system is learning from, it's mission accomplished, right? You are gonna generate antibodies against SARS coronavirus 2. But even if you don't, you're still generating some antibodies, right? What's much more dangerous? SARS coronavirus 2, right? I think it would be almost impossible to demonstrate something is more dangerous than the evidence right in front of us from SARS coronavirus 2, right? Definitely, unquestionably more dangerous. And by the way, even in people who get infected and they're asymptomatic and they don't have any, they don't have any symptoms, they don't react at all, we don't know what's going on there. We don't know if they just, the virus failed to, it just didn't really colonize very much. They just had what's called a small inoculum. They had a small dose, let's say, when they were exposed to the virus. Or if their immune system just isn't reacting and this virus is just going to hang out there for a while, right? We don't know that for sure. I mean, that's probably not the case, almost certainly not the case, but we don't know for sure. Okay, one thing I wanted to bring up, which I think is it's super cool, and I think these scientists from BioNTech, these in Germany, these scientists need to get, they did just get a prize, actually. They just got a prize in Germany, but they need to get a bigger prize. And I should also note their valuation, the valuation of BioNTech has skyrocketed. I think it's something like $21 billion, overnight. And hey, this is a system in which we operate. They deserve, if anybody deserves that kind of an increase in value, right? I think BioNTech has earned it. But anyways, here's what's really, really cool about the mRNA vaccines. First of all, they made those vaccines in a weekend. Right? Once, China released, or the Chinese scientists released the sequence of SARS coronavirus 2, this group, who had been working on making these mRNA vaccines for something completely unrelated, obviously, we didn't even know that SARS coronavirus 2 was a thing, but they weren't even working on viral pathogens, right? They were working on a different application, but they literally composed the sequence, the mRNA sequence, for the Moderna vaccine, or I should say the Pfizer-BioNTech vaccine, but same goes for Moderna, like that. You can change the sequences of these vaccines trivially. The production is a challenge, or you need to make a lot of vaccines really fast, but it's trivial, right? So that's remarkable. But okay, so here's the coolest thing. Well, the coolest thing is that this vaccine is already saving countless lives, right? Both among people who get vaccinated, but also people around them who can't get vaccinated. Their lives are also saved. But this company had been focusing on making vaccines for cancer. That was the purpose of BioNTech. That was the main goal of the work at BioNTech, was making vaccines for cancer. And it just so happened that they decided, like, hey, we have this technology. Let's make vaccines for SARS coronavirus 2, right? It's a vaccine after all. And they did it, right? And they called their effort Project Lightspeed, which is, pretty cute. And here we are today, fortunate to be the beneficiaries of their genius. But that doesn't mean that these mRNA vaccines, which once again are remarkably effective against the SARS coronavirus 2, right, viral particle, against COVID-19. Who's to say they wouldn't be similarly effective against certain things that cause cancer, right? And how would that work? So, there's different types of cancer, right? It's not quite, but it's almost a misnomer to conceive of cancer as being just one disease. It's sort of like a whole spectrum of slightly different types of diseases, but they all essentially emerge. What they share is that it's aberrant cellular growth, uncontrolled cellular growth, where cells are just proliferating and ultimately impinging upon the function of other parts of your body. And, your immune system has the capability, and your immune system oftentimes does, recognize when a cell is behaving aberrantly. It's not producing the right proteins, or its proteins are misfolded, or, it's just doing something it shouldn't be doing, or it's doing something it didn't evolve to do due to some kind of mutation, right? So, this system we are fortunate to have, and it keeps us safe in many cases, right? But we have these mRNA vaccines. So think about this. You take a biopsy of a tumor, right? That's consistently done when there's a concern that somebody might have cancer. It's biopsied. A little slice of the tumor is removed and then, assayed. And then, does this have an estrogen receptor? If it's, breast cancer, is it estrogen receptor positive? Is it negative? And of course, now we will sequence the cells, or we can sequence the cells to get an idea of, okay, what in this cell is aberrant, and then you could theoretically vaccinate against that and then train your immune system to attack that cancer, right? That would be completely game-changing. And I am thrilled that these brilliant scientists, it's a couple, both, by the way, immigrants from Turkey to Germany, I believe. Yeah, Uyghur Sahin and Özlem Türeci. I believe, I'm not as familiar with Turkish pronunciation, but I believe that's how you would pronounce it. Or Uyghur, I think, Uyghur, Sahin and Özlem Türeci. Anyways, this couple, I'm very glad that these brilliant scientists have worked on a SARS coronavirus 2 vaccine. And by the way, these companies are exploring. God, I could go on and on about this, but they're exploring, okay, let's make new vaccines. Let's modify these vaccines so that they're more effective against these new strains. But I'm really glad also that they're working on vaccines for cancer. Like, that is huge. Okay, sorry. I was sort of fanboying a little bit there. Keep being dropped off the broadcast. Oh, sorry about that, Issa. Yeah, Perry's falling apart. Yeah, I'm sure there's nobody on the ones and twos at Periscope headquarters these days. Okay, something wrong with you, or the one said going ban me for, I'm trying to get an answer. Okay. Jesus, did this you think funny? This is not a joke. I'm not sure what you mean. I predict a vaccine booster, probably this fall for the variants, hopefully. Yeah, I mean, I don't think you're far off. It'll depend. So here's what's interesting. Was that a bird? Did you hear that? That was crazy. So there was a recent study that came out of, where was it? It was, whatever. It was essentially an assessment of the, what is it that has changed in the sequences for these variants. And what's cool about it, or what's comforting about it, is that generally speaking, all of these variants have some kind of change in a sort of a cluster of the sequence of SARS coronavirus 2. So it's not like there's just like infinite numbers of variations on SARS coronavirus 2, and like it'll just constantly, there'll be constantly new variants. At least as of now, it doesn't seem like that's the way that SARS coronavirus 2 is evolving. What seems to be the case is that there's convergent evolution is what we would call it. So, you have a variant emerge, or at least detected in the United Kingdom, in Kent, I believe, B117. And then you have a variant detected in South Africa. And there's variants all over the place now, right? In California, in New York. But what's comforting about them, despite the fact that they are more dangerous and more difficult to respond to, and potentially more difficult to vaccinate against, is that there seems to be a selective pressure for these variants to emerge due to changes in pretty much the same sort of component of the SARS coronavirus 2 virus. And so therefore, we don't have to worry that like there's just always going to be a new virus that emerges, and we're just never going to have a vaccine that's capable or a set of vaccines that are capable of fighting against it. So that's a good sign. But anyways, you could totally be right. And one of the reasons, by the way, I see a lot of people say that they want the Pfizer or the Moderna vaccine because they're so effective, and the J&J vaccine was suggested to be slightly less effective, like inconsequentially, trivially less effective. But you have to keep in mind that the B117, this UK variant, which we shouldn't really call it that because it didn't necessarily emerge in the United Kingdom. It was just detected there because the United Kingdom is doing the best job in the world of surveilling genetic surveillance, because they made the decision to invest in this before we had a pandemic. The United States is doing an atrocious job. It is unforgivable that we are not contributing more genetic surveillance data to the world, given the capabilities that we have, right, in this country. Right. Well, so in any case, so you could be right about the emergence of new variants that will require booster doses, but it might be the case. Oh yeah. So sorry about that. So the J&J vaccine was tested at a time when this variant existed, whereas the Pfizer and Moderna vaccines were not tested. This variant, at least as far as we know, didn't exist yet, and so all this to say, the J&J vaccine is very, very effective. And I know that they're evaluating the efficacy of the Moderna and the Pfizer-BioNTech vaccines against the variants as well. But so, you could be right, but they do seem to be pretty effective against the variants. Maybe not quite as effective, but once again, these variants arise from changes in the same sort of region of the viral particle. So it could be the case that, so long as we get enough people vaccinated quickly enough, we'll be able to. It's a race against evolution right now, viral evolution. But I wouldn't be surprised. You could be right about that. Okay. Don't give up. You are worth it. Oh, he answered the other person's question and said it was me, Prentice. Even doctors run for me. Hell yes, I do. Everyone ignores me. Okay, I tried to kill myself twice thinking about it again. Well, Prentice, smart people want to make me shoot my brain. So, Prentice, it sounds like you really need counseling. Okay, I got brain damage December 2014. I want to know how I can heal thinking about stem cell, Panama, or hype. Okay, I don't know. Maybe you mean, I don't know if stem cell treatments are available in Panama that are not here. That might be the case. There are certainly stem cell treatments that are available outside of the United States that aren't. Or that outside of the United States that aren't available in the United States. So maybe you're talking about that. So when it comes to traumatic brain injury, that is a really, really difficult, which is what I believe you're describing, maybe from a car accident or something like that. It's a really difficult condition, because we don't, most of the neurons in the human brain do not regenerate. So once they're gone, they're gone. That's not true in all parts of the brain. There are certain parts of the brain where what's called neurogenesis, the creation of new neurons, continues into adulthood, but the majority of the brain does not host that kind of activity. Oftentimes, or what happens when somebody has significant brain damage is glial cells will begin to fill in where those neurons that have now been removed once were, and once glial cells are there, it can be very difficult to replace them, right, with neurons. And, of course, we are not at a phase in regenerative medicine, the use of stem cells, for example, or neuroprogenitor cells. We're not at a stage in that science where we'll be able to apply that. However, there was a recent study that I talked about on YouTube, youtube.com/anthropoid. Well, let me see if I can find when I did. Not that long ago. Let's see. I think it was... Oh, well. I thought it was more recently. But anyways, a potential novel treatment for Parkinson's disease using what are essentially stem cells, using neuroprogenitor cells. So we know Parkinson's disease arises from the progressive deterioration of a specific type of cell, a dopamine-producing neuron in a part of the brain called the substantia nigra, due to just aggregations of misprocessed proteins called alpha-synuclein. But anyways, these neurons are sort of like right at the bottom of the brain, sort of bottom sort of surface of the brain, where the brainstem kind of plugs into the cerebrum. And there is now some evidence that, and literally, testing in humans, that injecting several million neuroprogenitor cells can potentially either stop the progression of Parkinson's disease, and potentially, theoretically, it might be able to reverse it. So when it comes to traumatic brain injury, theoretically, it's a specific region of the brain that's been damaged, and the cure would be to replace those neurons, right, with neurons that are not. And so theoretically, Parkinson's is sort of like an ideal way to test. The prospects of regenerative medicine, because we know precisely where these neurons are that need to be replaced. And we know and more importantly, we know what kinds of neurons they need to be. They need to be dopamine-producing neurons from the substantia nigra. When it comes to a traumatic brain injury, that will not be limited to any one type of neuron. It's not like only serotonin neurons, serotonergic neurons will be damaged, or only glutamatergic, or only GABA, or dopaminergic. It's a region that is damaged. But theoretically, down the line, years down the line, we could come to a point where, okay, once we know what kind of neurons were involved, you could at least recuperate a lot of lost function through the use of regenerative medicine, through the use of stem cells, neuroprogenitor cells, which are basically stem cells that are going to be a neuron of some kind. So yeah, unfortunately, I wish I could tell you that we are at a stage where that is ready to be deployed, but we are at a stage where that is being tested. Okay. How effectively can... Hey, Abyss, good to see you, man. How effectively can cognitive reserve compensate for neuronal death in the brain? So yeah, I'm not 100% sure this is the thing to which you're referring, but part of recovery from any kind of brain injury, that can be a traumatic brain injury, but also a stroke. Part of the recovery is just the response of the remaining neurons that are not damaged in essentially adapting and oftentimes co-opting the activities of the neurons that were damaged by whatever the insult was, stroke or traumatic brain injury. And so that takes some time, which is why physical therapy for strokes for people who have had locomotor or motor loss, paralysis or loss of motor function in certain parts of the body, or sensory loss. They no longer can feel certain parts of the body, and then also cognitive, the loss of the ability to spell or to speak, right? These types of things. The reason that people can recover function there is that it just takes time for the remaining neurons that are still there to either expand their already pre-existing the function they already had, or for neurons that were not involved in the parts of the brain that were damaged to become involved. But of course, I can't quantify that for you, but we do know that it's a thing, right? That it happens. Okay. If I injected COVID-19 vaccine directly into my brain, what would happen to me, Mr. Brainologist? Okay. If I injected the COVID-19 vaccine directly into my brain, this is an answerable question, right? Well, it depends on which vaccine. So let's just focus on the mRNA vaccine. So here's what happens. The same exact thing that happens to your shoulder muscle cells when you receive the normal mRNA vaccine would happen in the brain. These lipid-coated mRNA sequences would gain entry to cells, both neurons and glia, I would imagine. The mRNA hosted within would be exposed to the cytosolic compartment of a neuron, the sort of the inner soupy part of a neuronal body. the enzymes, polymerases, the types of things that create amino acid sequences and proteins from our mRNA sequences would create protein from the mRNA sequences from the vaccine, and that would be the spike protein from SARS coronavirus 2. And the same thing would happen. Now, the reason you wouldn't want to do that in your brain is the brain is largely what we call immunoprivileged, right? So B cells, T cells, they don't really gain an entry to the brain. In fact, the majority of the immune system, both innate immune system, the complement system, macrophages, these natural killer cells, these types of cells don't interact with the brain, but also the secondary immunity, the B cells and T cells. That is a peripheral system. But the brain does have an immune system of sorts. It has a type of cell that sort of functions kind of like a macrophage. It has phagocytic capabilities, meaning that it can bind something and engulf it and then chop it up. And so you would have some reaction, right? Because that spike protein is not supposed to be there, right? It's foreign. And so you would have an inflammatory reaction for sure, and it would probably be pretty dangerous. And I don't think that it would actually provide any real benefit either, like, because it wouldn't, because you wouldn't have, the whole purpose of vaccination is to acquire secondary immunity and antibodies against, and B cells and T cells and antibodies against a given pathogen. You wouldn't generate those in the brain, and you would just have an inflammatory reaction, and it would probably damage parts of your brain. So that's probably what would happen. I don't recommend it. I'd much rather the shoulder for me. Okay. Do you have any thoughts on focus pills sold at local pharmacy? So, who did it? That's your handle. I love it. So, by the way, I should repeat, I have a YouTube channel. So, as we know, this will be the last time we chat with each other on this platform. I have a YouTube channel, youtube.com/anthropoid. Check it out if you're interested in sustaining our conversations. If you're interested in trolling me, I'm all for it. Come at me. But then also another platform called haps.tv. And I have links to both. That is another live streaming platform. And some of the coolest people I've ever met are already there. Both Isabel Betancourt, bug scientist, entomologist, and Deanna C. Hooper, who is a theoretical physicist. She talks about the actual hard questions about, like, where the universe came from, like that kind of stuff. What is dark matter? She literally studies that. Or is it dark energy? I can't remember which. Or probably both, I guess. You probably have to study both if you study one of them. But anyway, so check it out, haps.tv on your browser. But then I also have a link in my profile. All right. Mr. Brainologist, man, I love it. Okay. Yeah, I predict a vaccine booster. No, I didn't think it was a joke. Okay. Oh, I was going to suggest that the timing when the vaccines were tested determines Oh, geez, Abyss, I didn't realize you've been here for this long. I'm sorry about that, man. I was going to suggest that the timing when the vaccines were tested determines the efficiency. Yeah, I mean, I'm sure that there is some functional difference given the fact that, the no dark energy for me, only dark matter. Got it. Okay. Well, just as cool, in my opinion. Given the fact that these are modified adenoviruses and the others are mRNA. So, I mean, you are inevitably engaging systems using the modified adenovirus strategy, the Oxford AstraZeneca, the Johnson & Johnson, the Sputnik 5 produced in Russia. You're going to engage your immune system, right? Inevitably. But it just so happens that this adenovirus is basically harmless. And it's also replication incompetent. So, it's not like a normal one. And just given the fact that, like, the Sputnik 5 strategy is to have these two different adenoviruses, whereas Oxford AstraZeneca doesn't, right? It's just one. The concern in Russia was that you would develop an immune reaction to the vaccine virus, right? And so that could potentially degrade your immune system response, right? And the mRNA vaccine, that's not a problem, right? But I mean, ultimately, I agree with you. Like, these are effectively comparable in efficacy, and I would gladly receive any of them. And I was deeply, eternally grateful for the opportunity to get it, to get the Moderna one. Yeah, I would have taken any one of them. I'm a big guy. I'll destroy you. You're probably right if you're a big guy. Okay. So, yeah, how effectively. Okay, cool. Thank you. Sorry for being mad. They teased me. So, Prentice, I'm not sure. It makes me crazy. They teased me. Felt suicidal for a second. Have been in counseling. Okay, I assume you mean counseling. Well, that's good. I'm glad to hear that. I mean, I'm glad to hear that you're getting counseling. I'm sorry to hear that you were teased. I had neuropathy, and all top neurologists said nothing. Why am I doing this? I always do this. Why crane my head to the side when I can just not do that? Okay, it took me this long. It took me 5 years to figure it out, right? Where I don't have to look to the side like a weirdo. All right, neuropathy. And so nothing can do. Took tonic water with quinine, and it worked. You had neuropathy induced. Oh my God, are you serious? Ugh. Induced. It depends on what that was induced by. So quinine has some interesting properties, but had nothing to do with suspect most sources of damage to the brain. Okay. Whoa. Periscope banned you from requesting to cash out your super hearts. What? That's crazy. Yeah, I turned it off just because I didn't want people to provide them on the platform. So if you have no reaction to the COVID jab, does this have any bearing on whether you made antibodies? It's a great thing to think about. So the short answer is no. That doesn't mean that you're not mounting any immune response, but the converse is true, right? Where if you do have an immune response, if you do have chills, if you do have fever, these types of things, that doesn't mean that you're mounting an immune response. But that does not mean that if you don't have those things that you're not going to have an immune response. It would be interesting to see a comparison of efficacy of people who have severe reactions to those who don't. The thing is that it just tends to be the case that it segregates by age, where generally speaking, younger people have more severe reactions to the vaccine than older people. And we know that there are differences in immune responses that distinguish those age groups. So it may or may not have any kind of functional consequence regarding that young people are mounting a better immune response, not because they had that reaction, but because of their age relative to people who are older who had a lesser reaction. But what I would want to see is a comparison. It would be interesting, but I would imagine that it's just the age, the effective age. Well, not just, but mostly an effective age. Oh shoot! I saw somebody was just calling in. Please feel free to call back in. Jade Green Eyes. Oh, I remember your handle. So what's my Periscope exit strategy? I am using 2 platforms right now. youtube.com/anthropoid, link in my profile on Periscope. And I'm also using haps.tv, another live streaming platform that is relatively new. And by the way, one of the cool things about that is that it's still in this sort of phase where it's being determined what that platform is going to be like, and so you can influence that by participating at an earlier stage. So check it out, youtube.com/anthropoid and then haps.tv/anthropoid, but both links in my profile. I imagine that's easier. All right, getting a call from someone I suspect is named Rai. Is that your name? And if so, where are you calling from? Cool, San Diego. What's up? Oh, no. Well, always wonderful to hear from San Diego. From San Diego. I used to live in California. Can we ask questions on HAPS? Yes, absolutely. Yes, that is one of the reasons that I like using it. Do you think there will ever be a cure for dystonia? Yeah. These conditions that there's nothing like non-physical about these conditions, right? They obey the laws of physics, and as a result, they can be engaged. My daughter's laughing in the background. It's very cute, and they can be engaged therapeutically. So the only thing that distinguishes our ability, to cure them now is just a deficit of knowledge. So we just have to learn more about these conditions. I had Pfizer, no reaction. Yeah, but my parents too. My parents are not young. So, I mean, everybody, the immune system is a very interesting beast, and it varies a lot. And so, it's unsurprising that some people would have a more severe reaction than others. And, frankly, it's like, people have different reactions to SARS coronavirus too as well, right? Again, some people are totally asymptomatic. Some people don't even know they ever had it. And some people pass away from it very quickly, right? That is a giant delta, right? That is a giant spectrum of reactions. And so, when it comes to the immune system, there's a reason I decided not to go into immunology, although I had to take, actually, one of my classes, you might recognize this name, one of my classes in immunology was led by Dr. Peter Hotez. And he, whenever I saw him like in the halls this is when I was back at Baylor College of Medicine in Houston, he just looks like Bilbo Baggins. I would see him, and he is shorter. I don't know, he's probably my height. I don't know, but he's not a very tall dude. And he, wears those circular glasses, and he wears bow ties, and he obviously always has a physician's coat on, but he dresses nicely, and so it just looked like Bilbo Baggins was teaching me about the complement system. Anyways, if your daughter were a teenager, would you let her have the vaccine? That's a fair question, right? In my mind, they're doing trials right now on adolescents. And I think we will know pretty soon. Well, actually, rather soon, because these trials have been going on now for a while. I mean, frankly, we will know within 6 weeks of the start date of when enough adolescents were vaccinated, because, and I don't think this is widely appreciated, reactions to vaccines tend to occur within 6 weeks. It's almost unheard of that somebody will have a reaction way, years later. All right, San Diego, what's on your mind? Are you there?
Hello. Sorry, lost connection earlier.
No worries. What's on your mind?
Good. Just sitting here taking a poop, and I thought,
Thanks for sharing, man. That's important activity. I think a lot of people underestimate the importance, the significance of the microbiome that could be detected by your fecal sample. So thank you for sharing, San Diego. But anyways, yeah, so we will know pretty soon how adolescents react. I mean, the concern isn't that there's something toxic about the vaccine, right? That is not the concern. And of course, we vaccinate infants, right? We vaccinate people who are very, very young and with no negative effects at all. In fact, exclusively benefits. And so there's every reason to think that we will be able to vaccinate adolescents, which will be great. So that's my expectation, is that yes, and if it's approved, then 100%, absolutely. So we are fortunate on our last day together to get to chat with one of the most interesting people on the platform, Abyss. What's on your mind today, man?
Thanks for the intro, Ian. Yeah. So I called to sort of ask a question based on some of the cognitive reserve that I was talking about. Of course, it's known that cortical neurons are kind of hard to replace after after they die, after they go through apoptosis. So, you mentioned that glial cells, especially astrocytes, will be filling in for neurons, but up until this point, there are some instances where astrocytes can actually function or double as neurons.
Yeah.
I remember reading SCN seems to have interference with the astrocytes to function well and keeping circadian rhythm.
Oh yeah, okay.
I read that research a long time ago. I'm really searching for it right now. I can't find the paper, but so. Do you think it's really a bad idea the fact that astrocytes would start filling in for neurons, for deceased neurons in the cortical area? That's one question. And also, I don't know if you heard about this research where they are effectively reverse or at least change astrocytes into neurons in the striatum. So do you think that's also applicable for cortical neurons?
Dude, 100%. I mean, as you started talking, that was what I was thinking about, is actually, differentiating. I think that's basically how they do it into neurons. Yeah, I mean, that would be really, really interesting. Certainly. And so when I assume you're talking about the suprachiasmatic nucleus, right? Yeah. Okay. So yeah, I mean, it's an interesting thought, right? For sure, like some of the recovery that people can can exhibit has to do with the fact that astrocytes or glial cells in general, but astrocytes are versatile. They're more versatile than just then I think they're appreciated for being. So, by the way, just so everybody understands, astrocytes are a type of glial cell. Glial cells are, we all think about, when we think about the brain, using the brain to think about it, we tend to focus on neurons, right? Those are the excitable cells. They are probably the most important cells in the brain, but we have this whole other category of at least as many glial cells, and astrocytes are probably the coolest ones. And so, they share a lot of features, right, with neurons. They do have sort of processes, and they're dynamic, and they do form connections with neurons. But I just think the reality is that the differences matter when it comes to, and maybe in certain brain regions it wouldn't be such a big deal. Brain regions that don't deal with like super high frequency firing, right? I could imagine things like that. But I think that there are certain properties of neurons that are that could not be accommodated by an astrocyte. But what I think is more interesting would be using that strategy to just turn some of those astrocytes into neurons. I mean, we could only speculate. I don't remember if the group or groups that did that did any kind of like functional behavioral assays or anything like that, or if it was just in vitro. Do you remember that?
It's probably in vitro, but I have to go through the paper to find out. But I bet I'm not sure.
I bet it was in vitro. So meaning in a for everybody else, meaning that in a petri dish, right? And so it would be interesting to see what the functional consequences of. And like trying to limit that, because you don't want to get rid of all your astrocytes, right? So you just want it to be, regionally limited, spatially limited. But it would be an interesting experiment. If it hasn't been done yet, I mean, that's a low-hanging fruit. Somebody's got to do that experiment. I would, consider even joining a lab to try and do that, because that would be really interesting. But anyways, yeah, I mean, but frankly, my expectation would be that the simpler thing to do, as difficult as it is. Well, yeah. So the simpler thing to do, I suspect, would be to try and respond as rapidly as possible to the traumatic brain injury with neuroprogenitor cells that are, differentiated as much as possible to become the types of neurons that you intend for them to become. But then, and I think what you're really implying is that people who have had a traumatic brain injury for years, and the gliosis has occurred, and those spaces are filled now by astrocytes, at least in part. Being able to just down the line convert at least some of those, that's an interesting prospect. Yeah. But I'm looking forward to the functional paper, to seeing if somebody's done it with an animal.
Yeah, exactly. Me too. And also, I remember some of the, at least from imaging point of view, the cues for rehabilitation, neural rehabilitation after stroke or any kind of severe brain trauma, is the increase of the gray matter, which is like the cell body of the pyramidal cells. So I don't know if that's going to be, if that would mean that there will be more regeneration of the pyramidal cells, because it would the effect kind of compounds, right, when you're affecting different types of neurons. Like if you affect like the horizontal neurons, I think that would transfer all the way from cerebellum, and they're kind of like wiring the entire brain altogether. I think that would have like a more profound effect than pyramidal cells. But we know pyramidal cells are very essential for sensory motor organization and
rapid activity
function. So I'm like conflicted with that. Like I was always curious, like how you can attribute the increase of the gray matter thickness to like how the mechanism actually really works, because we know that the increase is associated with, like I said, rehabilitation or increased cognitive function. That makes sense.
Yeah, well, I mean, are you basically like speculating as to what recovery of certain neuronal subtypes may account for differences in how effectively people recover? Is that what you're suggesting?
That's right. Yeah. I worded it poorly.
No. Your word is just fine. I just, making sure I'm keeping up. Yeah, I mean, it's an interesting thought. I would imagine that it's just going to completely vary depending upon what brain regions are affected, right? Like, if somebody has a stroke and there really aren't any motor, sensory, consequences or symptoms, I could imagine that, other weird neurons, neuronal subtypes, would need to be involved. But yeah, I mean, I could only speculate, whether or not one is just, let's say, more important, right, to recovery. But it's an interesting thought.
Yeah. All right, that's all I have.
All right, man.
Thanks for letting me in.
Yeah, of course. And I look forward to chatting with you again on haps.tv.
Yep, definitely.
All right, take it easy, man. Yeah, so, and just to make it clear, I am using two other platforms after we bid our beloved platform a fond farewell. I'm using YouTube, youtube.com/anthropoid, a link in my profile page, and haps.tv, HAPPS.tv, also a link in my profile page. Speaking of YouTube, this is what you get when you mess with us. Oh, welcome back. Welcome back to you. Yeah, whenever I read, this is a comment on YouTube. Whenever I read your handle, this is what you get when you mess with us. First of all, it's one of my favorite handles, but also I think it's just part of I think that's the comment. But anyways, yeah. Do you think that the antibody testing for COVID-19 is accurate? Do you have any information on how long COVID-19 antibodies will show up in your body for? Yeah, king of comments. It's certainly an interesting thought. So, are antibody tests for COVID-19 accurate? Yes, they're accurate, but they have a different purpose than, like, I assume you're referring to PCR testing. Because for PCR testing, you are that's polymerase chain reaction. You're literally testing for the presence of viral particles. Like, are there viral particles there at all? So you know if you're exposed. Antibody testing is more beneficial to evaluate whether or not you are exposed ever, or of course, whether or not you have antibodies. So, you either do or you don't, right? And so they will be effective. They will be accurate. The question isn't its accuracy; it's the application of the proper test, right? And then, do we know how long COVID-19 antibodies will show up for your body in your body? That's another very interesting, obviously very important question. We have some lines of evidence with which we can work to speculate. So first of all, we know, and people have done antibody testing on people who have recovered from COVID-19, and first of all, we know that all coronaviruses, immunity begins to deteriorate. And so, it's not like, chickenpox or something like that, where you have very long-lasting immune system memory or antibody memory. So, I think it's pretty widely expected that we will, antibody protections will deteriorate. Which is one of the reasons that it may be the case that along with your flu vaccine, you'll get a COVID-19 vaccine. It's possible. Not inevitable, though, because the influenza virus, mutates much more rapidly and regularly than does SARS coronavirus 2, believe it or not, which is why, you can't have a vaccine that's effective perpetually for the influenza virus. So COVID-19, SARS coronavirus 2 does not mutate as rapidly. It does mutate. All viruses do. But it's a different type of virus. It's a coronavirus, and so it may be the case that we won't have to do the sort of seasonal vaccination, but we'll see. So we know that immunity to coronaviruses tends to deteriorate. We also know that some people now who had come down with COVID-19 had a reaction to it, right? And then recovered, which inevitably means they did mount an immune system reaction, they have an immunity or antibodies against it, they have been reinfected, suggesting that whatever antibodies they had were either ineffective, which is possible, or ineffective due to a new variant or something like that, or that the antibody memory just degrades and you're only immune for a period of time. Or you only have immunity for a period of time. Keep in mind, like, even if you have antibodies, you can still get infected, right? The question is how severe your reaction is to that infection. And so, as far as I know, it is anticipated that it'll be many months that people have immunity from antibodies. Oh, another interesting phenomena phenomenon that has been observed is that it seems to be the case that antibodies generated by vaccination may be more effective than the antibodies that are generated by being actually infected with the virus, which is really interesting. And like I could speculate as to why that might be the case. Specifically, I think it would be because antibodies can be generated against pretty much any, not any, but other parts of the viral particle that are not the spike protein. And if you have antibody, it may be the case that those antibodies are just less effective. They're effective enough for you to recover, but they're not as effective as if you have antibodies against the spike protein, which is what all the vaccines target. So I would suspect that accounts for it, but that's an interesting observation. But anyways, so I think the expectation is that we'll have several months worth of effective immunity against SARS coronavirus 2 after vaccination, and then it'll just be a sort of like steady increase in vulnerability. And again, it's not vulnerability to being infected; it's vulnerability to reacting severely. And so you can just think of it as sort of like a gradient, or maybe more like a clock, where the longer out you go from your vaccination, the more likely you are to have a reaction of greater severity. So that's how I think about it. But we don't know for sure. It could be the case that because the antibodies generated by vaccines are so effective that they last longer, and so long as you have any antibody memory, you'll be able to mount an effective reaction or immune system reaction and prevent you from having, a really, really severe reaction. So that could also be the case. But we'll have to just wait and see. Yeah, and I can assure you people are thinking about that. Okay, very true. Okay, so do you miss California? Yeah, I do. I love Philadelphia. It's my favorite place I've ever lived. But it's really difficult to compete with Southern California. It's difficult to compete with Northern California. It's a beautiful, beautiful state. But I do like Philadelphia better. And I've lived in Texas, Houston, Texas. I've lived in Florida, in Colorado, in California. I spent several months in Canada, in Ottawa. I've lived in Puerto Rico, and they all have their unique charms, of course. But Philadelphia is, if I can stay here, I would like to stay here. It is awesome. My pleasure. Thank you for bringing up. It's an important topic. Thank you for bringing it up. I see. Okay, I've set up a point of contact, but no use yet. Oh, seems complicated. I'm on here. I'm not used yet. Oh, can we ask a question on hats? Okay, got it. Sorry. Yeah. Yes, you can. Okay, so I've had it, but unsure about my daughter. Your daughter, I see. Okay. So, and I assume Jade Green Eyes, your daughter is adolescent. It's an interesting question as to if I were in the position where my daughter's 2.5 years old, so she's not really although I do believe they're starting a vaccine trial in rather young people. Do you know why our vaccine cards have 4 data slots? It's an interesting thing, right? My suspicion, Issa, and I don't think Issa's still here, but my suspicion, the reason you have your vaccination card has multiple levels is that it's probably just a standard form for all of the vaccines, for pretty much every vaccine, and that's how CDC, Centers for Disease Control, that's what they use for, regardless of what kind of vaccine you get. That's just one of the forms that they have. And hey, maybe they're just like, hey, maybe we're going to need 4 vaccines, but I suspect it's just a standard template. It's like you guys are speaking a foreign language, but so fascinating. Oh, Patty, I suspect, maybe Abyss. Yeah, Abyss, he's familiar enough with neuroscience to speak the language, which I can understand as being a little bit inaccessible, which is why I try and do my best to define at least what I think are the important parts, like SCN, suprachiasmatic nucleus, pyramidal cells, these types of things. Thanks for the content these years. Oh, Rock, thank you for joining me all these years. And I hope you'll join me on, these other platforms, youtube.com/anthropoid, link in my profile page on Periscope, and haps.tv/anthropoid, link in my profile on Periscope. So it would be a shame from my perspective if it would be a loss for me if I am unable to continue chatting with people all over the world about neuroscience. That would be sad. But so I hope you all will join us Deanna C. Hooper is here too. She's a theoretical physicist, and she talks about the universe. She's over there. We also have Isa Betancourt. Isa Betabug is her handle. Talks about bugs, really, and access to really cool specimens. We met. She still is sort of back and forth, but she lived in Philly and worked at a museum I can see from my window, the Natural Sciences, the Academy of Natural Sciences, I think, in a really amazing collection of entomological collection. She showed me their like the samples that they have in the back of the shop. She also made me hold a tarantula, which I wouldn't for Halloween. She sprung that on me, but yeah, that was fun. Anyways, yeah, and then also Christian Zassa's over there, probably the best astrophotographer I've ever met, certainly. So go check it out, haps.tv/anthropoid, and then also youtube.com/anthropoid. Are you live on Haps now simultaneously? Usually I will be. Yeah, starting tomorrow. I don't know if I'll be able to go live tomorrow, but starting tomorrow, I will be. It's a Radiohead lyric from the song Karma Police. Which one? Not Knife Jam? I don't remember that. Great content. First time viewer. Oh, Harry. Well, I hope you'll check out these other platforms on my profile on Periscope. Okay. Any other test other than PCR? Yeah, I mean there are other types of like the rapid tests. I believe are there. It's sort of basically it's like you set up a let's see what would be the way some of these other tests work is that you can imagine a vessel, whatever. Just imagine a okay. Imagine a chessboard, okay? So just imagine a chessboard, the checkered sort of thing, right? And on certain squares, you put little magnets, okay? Strong little magnets, right? But on other ones, you leave empty, okay? And you have this thing, it's maybe a ball, and you're curious as to whether or not it's magnetic. Well, one way to test whether or not it's magnetic is you could take your surface, your chessboard with magnets on it, and just put your ball that you're interested in testing whether it's magnetic on the chessboard. And if it sticks to any one of your magnets, aha, it's magnetic. That's how a lot of these other tests can work, where there's it's sort of like a receptor where, if there's successful binding, they know that there's the presence of COVID-19. They're not as accurate, but they're super useful. We should be using them more. How's Philly weather today? It was nicer earlier. Now it's a little gloomy. DACA got super aggressive after TBI. Will this ever go away? Prentice. Well, with therapy, yes, over the long term. And of course, there are medications that can help to help mitigate the severity of your symptoms. Do you have any new info on long haul COVID syndrome? Eusema, I do not have any. Eusema side boob. I do not have any. I don't know about any of the biology of the long haul COVID. So Eusema is bringing up the fact that some people, not everybody, but some people have really prolonged symptoms from COVID-19, but we don't know the biology. It's sort of a mystery right now. And then when it comes to the neurological symptoms that some people have, it could just be that because people there is a reaction in the brain, and neurons are lost, or there's just persistent inflammation. And the ramifications of pretty much any change in the brain can be very long-lasting. Not necessarily permanent, but long-lasting. But anyways, yeah, we don't know. Like is the complement system in the immune system, is the innate immune system like out of control or something? We're not sure. Hello, what's your name and where are you calling from? Are you there?
My name is Mariam.
Miriam. What's on your mind? And where are you calling from? From UAE. Oh, very cool. What's on your mind?
Nothing.
Oh, okay. Well, if anything comes to mind, feel free to call back in. And otherwise, I hope things are lovely in the UAE. UAE is a very interesting place. Pretty singular. We should consider lucky that COVID mutates less rapidly, not to undermine the loss of life, though. Yeah, no, totally. Blame it on my ADD, baby. That's Radiohead. Yeah. Did the Wuhan lab help with creating the vaccine? Well, yes. Well, I don't know specifically if it was the institution out in Wuhan, but of the many things that went badly over the course of this past year, one of the things that went well was how rapidly the Chinese scientists divulged their knowledge of the sequence of the SARS coronavirus 2 virus, right? That happened very rapidly, surprisingly rapidly after they detected it. Say what you will about the Chinese government and all this kind of stuff, like they're not necessarily known for collaborating really closely and openly with the United States, right? And that whatever that's international relations. It's not like unique to China, right? But the world of science is different. We voraciously collaborate with one another, and they did successfully then, and that's why we had a vaccine produced in unprecedented time. All right, we are getting some more calls. Very cool. Super Scooper. That's a fun name. Looks like we are connected. Super Scooper, what's your name and where are you calling from?
Okay, hi, hello, can you hear me?
I can. Roxy and Dio. What's your name and where are you calling from?
Yeah, I'm Anil. I'm calling from Turkey, Ian, and I want to say, before I ask my question, I really enjoy your content, and I'm kind of like a little bit of a geek when it comes to science. I really like to learn a lot of branches and stuff, and I'm just following you for like around 2 or 3 months now, and I have a burning question up in my mind, if you don't mind.
Please.
What I wonder is, my mother has bipolar, and like when I'm trying to make some researches about it, and like I'm really nervous. I'm not nervous. I'm curious about what happens to the neurotic cells, and like is it disrupted for eternity, or like how can we reverse it? She's taking medications for like 3 or 4 years now, but she's always getting ups and downs because she's a bipolar now. But like I'm trying to find a ways to how to recover from that for good. Like what is it like? What's happening on the brain wise? I would like to get your opinion about that.
Sure. Yeah. So bipolar disorder, it's very complicated. We know that it has a genetic component. That
Really?
Yeah. That it tends to run in families. It's not 100%. It's not like if your parent or her parents had it, then you'll inevitably get it, and of course, or you'll inevitably have it. You don't catch it, right? But yeah, like it arises from a unique brain architecture that renders the bounds of affect, the bounds of your emotional reactions to various things in your environment, just far more volatile, and so oftentimes bipolar. People with bipolar disorder can be difficult to treat because during periods where they are when they're depressed, right, they'll tend to comply with treatment and they'll take the medication and so on. But when they're not depressed, sometimes they'll just decide that they're cured or that they no longer need treatment. They no longer need to take their medication. So that is a challenge. But fundamentally, that's what it arises from. It's this unique brain architecture that we inherit. But then it also, everything in the brain, whether it's bipolar disorder or any kind of psychiatric condition, it arises not just from your pure biology, right? It's a byproduct of you could imagine the brain environment interaction, right? And so something precipitates these types of reactions. But what you're interested in is is this a permanent thing, or is there a potential cure? Let's say that would make it so that she would no longer need treatment. As of today, the best that we have available are the types of medications I'm sure she's being prescribed, right?
Prozacs and stuff.
yeah, SSRIs, SNRIs, these types of medications. Sometimes what can be used are atypical antipsychotics, which I know can be a sort of like a scary term for medication because it has the word psychotic in it. But it's not just relegated to exclusively psychosis or these types of conditions. And so but that's basically that's the armamentarium right now. That is the spectrum of medications that we have available. There's some interesting other medications that have been tested on bipolar disorder, like aripiprazole, which is called Abilify, I believe. has been tested in with bipolar disorder. And so, you know, but basically that's it, right? Because, you know, the condition isn't arising because, you know, somebody caught a pathogen, right? It's arising because they have this, you know, unique brain architecture. And so the question for me isn't, you know, and I've, you know, psychiatric conditions run in my family as well. Question for me isn't how do we make them normal, right? Or make them so that they don't have these conditions. It's to provide them the tools that they need to live a high quality of life. Because one of the things about these conditions is that they oftentimes are coupled, that unique brain architecture is oftentimes coupled with unique insights, unique ways to see the world, you know, unique cognitive, yeah, they can be extremely creative and just lovely to be around and really funny. Like, you know, certainly the people in my family who have these conditions. Yeah.
We're trying everything we can that she can feel normal again, but like she's retired, she's like everything is good. Okay, she had some traumas back then, but like right now she's taking her medications for like 3 or 4 years now. And when I see her and she's just telling me that I know what I have to do, but I do not want to do it, and I'm just, you know, like evaluating like the impact of the medications that are just exactly working or not. Because when you see it, like she's not stopping to taking her medications when she's going better. She's always aware of the situation, but she's just telling me that I don't want to do it. Like I don't want to get up from bed, and like it's just becoming surreal at this moment. Like we do not know how to recover, like maybe for a certain amount of period, because like the period time, like the when she's up, we cannot estimate when it's going to happen. Like it's just so sneaky disorder that and it's just making you try to understand how actually brain works and what happens actually inside of it. I just wanted your opinion regarding that, but it's just when you're looking from this like another point of view, you're just thinking like, is she being for real? Like how exactly, but like so interesting.
Yeah, sorry about that, man. I mean, I know, I from personal experience, I know how difficult that is. And yeah, I mean, it is the kind of thing where, you know, where it's just difficult to understand. I mean, that's true for every psychiatric condition, where it's difficult if you don't suffer from them. It's difficult to imagine what they're like. I think that's why a lot of people, you know, perceive depression as being this fake thing, right? Because they've never experienced it. They can't imagine what it's like to have depression. But I mean, you know, and that is a huge problem with all psychiatric conditions, including bipolar, is that these medications all have side effects that are unpleasant. And, you know, they can make people tired, but they can also just make people feel groggy and just not on top of it, right? And so, but, you know, so one thing to try potentially, you know, if she's really having, you know, difficulty, if she's just really reacting badly to the medications, is you can always explore other medications. Like there's Tegretol. Tegretol is a medication that has been used for bipolar disorder, but you know, you can talk to her physician and just say like, hey, you know, can we try something else, because like this isn't working for me.
That is what we're doing it for like for a couple of years. She's just tried a lot of professors and stuff from other cities and other, you know, like counties and stuff. But I think the main point is, you know, and I also wonder, like they also give like some kind of serotonin, like the external pills. I think that just makes supposed to make her feel happy with that hormone or something like that. But like apparently it's not working either. It's just but thankfully, you know, when she's down, she just lays down and she just, you know, like passes the day. And like it's not you know, from our experience with my mom, there's nothing bad happening. She's just laying down, and so, magically the next day she just wakes up and she's just feeling great again. And it's just interesting. But I really wanted your, you know, like opinion on that, and thank you for detailing the question that I have for you, and I really appreciate it.
It's my pleasure, man. Thanks for calling in, and best of luck.
That's all right. Okay, thank you. Have a nice content, live.
You too, man. So Neil, pleasure to talk to you, Neil. And by the way, Turkey is the source of a ton of really, really good research. You know, Yeah, we early on, when I was starting my PhD, we collaborated with a professor who ended up, or scientist who started in Turkey, ended up here in the States. But yeah, I mean, you know, and increasingly, it seems like more research is coming out of Turkey. Oh, sorry, I just missed somebody who was calling in. Feel free to call back in. I'll keep my eyes on there. Until then, can I receive a Neuralink without FDA approval? I'm ready now. I believe I would make a perfect candidate for the scientific forward movement. So I am sure that Neuralink would never do an implantation absent FDA approval, just because that would get them in a lot of trouble. And I don't think that Neuralink, so for anybody that's unfamiliar, Neuralink is a company that was started by Elon Musk. It's a whole brain computer interface company where they're planning on implanting things into the brain and that enable computer interaction. And they're just not at the point where they're ready to work in humans. But they are working in non-human primates. They're working in monkeys now. All right, it looks like we are connected. What's your name and where are you calling from?
Hi, Ian, can you hear me?
Yes.
Hey, I just wanted to say thank you. I finally took the liberty to try to join you after all these years, but I just want to say thank you very much for all your broadcasts. You've been an amazing broadcaster, so informative. You've sparked so much conversation in us, and I've seen it since day one on Periscope here, and I'm really going to miss us having this opportunity to chat and just delve in some Sundays where I'm just kind of feeling a little bit low. You really, kind of brought us back up again, and one thing I really want to thank you for is taking some stigma away from smoking marijuana. It's something I've done since I was really young. Can't say good or bad of what is what has come of it, but I will say it's something I'm not ashamed of it in life, and I've always had that stigma attached to it, where other people around me are drinking, they're doing other things that are I don't always believe that are let's just say I think that there's a bigger impact in some other things in this world than me kind of puffing a joint every once in a while.
Yep.
And you really, I think, inform people and to let them make a decision on their own rather than just kind of hearing and listening to others. So I think you brought a lot of great information. I really want to say thank you for everything you have.
Thanks, man. That is super generous of you to say, and I really, really appreciate that. It feels good. And I am benefited far more than I think most other people. And so it made me a better scientist and a more curious person. And so I really appreciate it as well.
We were definitely curious. I will say safely, I'm one that asks a lot of questions. And then this past year, 2 years ago, I started working in a hospital. I'm an IT guy. Best decision of my life to change and try to do something a little bit bigger than myself. And then I really felt proud of being at a workplace that is surrounded by people like yourselves. I work with a lot of doctors, a lot of nurses, a lot of specialists, and when I see what they do, like yourself, it's remarkable, and it's so selfless, and it's something that I finally feel like I'm surrounded by a bunch of good people. So congrats on I believe you finished your doctorate there.
Mm-hmm.
You've got a baby, or you got a little one on the way as well. And so just huge congrats, and that's all I want to say was just thank you for everything.
Thank you, man.
Best. All right,
I really appreciate it.
Everybody as well. Cheers.
Oh man, yeah, it is. It's sad, it's something I really enjoyed. It has been. It really. It helped me. It brought me from some dark times during my PhD. Definitely. When I didn't think I was going to be able to finish my PhD. Like, I just thought this is going to be impossible. I just cannot get this to work. And I would be able to chat with people and, who are interested in the topic, and they just, reminded me why I love this stuff, why I love this subject. And, so it has been huge for me. And there are these other platforms, right? I don't know if you can hear my daughter right now. She is just going ham on her new piano. She has like a little baby piano, just going nuts. Anyways, so there's haps.tv/anthropoid, or link in my profile to this new live streaming platform called Haps. And then there's also YouTube, youtube.com/anthropoid. I know the easiest word in the English language to spell. I understand it's super easy to spell, but you can check it out. Link in my profile on Periscope as well. Okay, when is Neuralink coming out, and can it cure reading disabilities? That's interesting. Nick Brown. So when is it coming out? Well, they have a device. I mean, like the device exists. They have it in monkeys, and they have multiple devices in monkeys now, according to Elon Musk, the founder of the company. And so, you know, it exists. Theoretically, it could be out reasonably soon. But when you're talking about Neuralink, I think most people are referring to the more romantic things that Elon Musk describes, like being able to interface with each other directly to improve or expand the bandwidth by which we communicate, where you don't have to like compress words and, you know, compress thoughts into words and then have those words filtered through your own personal experiences and stuff like that. And you know, those types of things, or being able to like play video games directly with each other without having to you know, mash your fingers around, that is not going to happen for a long time. At least that's my perspective. You know, I talked about this yesterday, actually. I'm optimistically skeptical. I do think it's possible. Like the goal, I totally think is possible. But I think that there are too many technological bottlenecks right now, like specifically miniaturization. These things need to be much smaller than they are. They are already really small, impressively small, but they need to be smaller. They need to be able to interact with more neurons. But then also just computer advancements. Like we need computers that are going to be able to handle gigantic data sets, like massive amounts of data, you know, moment to moment, wirelessly, and make sense of all of this data. So, you know, literal computer science discoveries need to occur for Neuralink to be, for, you know, the real dream of Neuralink to be realized, to come to fruition. And we're just not there, you know, we're just not there. And, but that doesn't mean that we won't be able to have treatments for certain conditions, like conditions involving, you know, certain motor movement related diseases. You know, there could be treatments, you know, fairly soon in, you know, the next decade or so, or the next 5 to 10 years. I have no real good way of, you know, actually speculating there, but, you know, something within probably most of our lifetimes. But, you know, the real dream, that's going to be, I would be very surprised if it, you know, if anything like that, even close like that, to that, came out while I was still alive, while my daughter is still alive, my 2.5-year-old daughter. And so, yeah, it'll be a while. And is there a limit to the amount of leads that can be implanted? Do the upgrades include the addition of leads, or is it a simple software update? I love that topic. Oh, and then reading disabilities. My apologies. So could Neuralink be used to treat reading disabilities? So, you know, so theoretically, yes. Theoretically, yes. You know, I could, and you know, right now what I'm thinking, when I say Neuralink, what I mean is like the dream of Neuralink, the main dream of Neuralink. When I think about, you know, that, with a true whole brain computer interface, then yeah, theoretically you could, you know, let's say, you know, you have dyslexia or something, and, you know, there's different, dyslexia comes in sort of different flavors, but one of them, for example, is like little characters, you know, like words, letters, will be reflected. And so, you know, you'll see, you know, let's say a B and it's reflected like that, right? Well, I guess that might have been a D or a B too, whatever. You see one, either a B or a D, a lowercase b or a D, and it becomes the opposite because it's reflected. But then there's also, you know, transposition versions where, you know, it's not like mirrored. It's like, you know, you see a B here and then you see a B up here. And it can be extraordinarily disruptive, right? So, you know, there's just different forms of dyslexia. And so, you know, it wouldn't be like correcting what the anatomical causes of dyslexia. It would be just bypassing those structures, right? And then just, you know, using the system to detect whatever those characters are, and then, you know, transmit the meaning, you know, their meaning, their semantic meaning to the rest of your brain. But think about it this way. Once you have a Neuralink, the need to read is going to be minimized, right? And I'm saying, again, Neuralink, I mean like the dream of Neuralink, right? The need to even read words is going to be minimized, because what do we use words for, right? We use them to transmit thoughts, to transmit ideas, meaning, right? Emotions, all of these things. And we wouldn't be here if we didn't have language, but it does compress all of those things, right? I say the word happy, and, you know, you filter that through your own perspectives of happy. And we're probably sort of on the same page, but, you know, I might be, what I might consider to be happy, you might consider to be contentedness or satisfaction, right? And so that's a deficit of language that's just inevitable. And of course, there's all these different languages and everything, but, like, you know, there is a compression effect that occurs where you're missing out on at least some of the nuances that arise from the brain activity that generates the thought happy or the experience of happy. And so instead of me writing that word out, or using the Neuralink to just transmit, like you just see happy, right, in your field of vision, or you just experience you just have the experience of having read the word happy. You don't even have to physically read it. But instead of that, I could just transmit just exactly what I intend to transmit to you in the form of the feeling, right? Like, this is what I mean. It's happiness mixed with contentedness, mixed with safety, right? Mixed with being full, and not being hungry, like all of these things. Or for some people it would be like, some people who are only happy when they do heroin, right? That when they think happy, they think I just did heroin, right? And so that's a different version. And so you could, directly transmit that as opposed to having to read it, right? And having to try and understand these nuances. And so that's where I would be. Like if I'm fortunate to not have dyslexia, but if I did, I would be excited for not even having to deal with reading. So yeah. All right, that was pretty long-winded. But hey, it's one of my favorite subjects. Will Neuralink be able to, this is all on YouTube, youtube.com/anthropoid. Will Neuralink be able to involuntarily control someone? Yes, awesome. I love it. Okay, this is one of my favorite things to do. Okay, so to talk about at least. Okay, so again, we're talking about a whole brain computer interface. This is a set of, oh wait, do I look crazy on YouTube? Oh, that's not so bad. So you have a whole brain computer interface, right? This computer, you're able to directly interact with computers, and then therefore directly interact with anybody else who is networked to this Neuralink system, this computer system. Okay. So as I was saying, you could theoretically, and again, this is not going to happen before I'm long gone from this earth, but you could directly transmit an idea, right? Or, you could directly transmit what you're seeing in that moment. Like imagine, you are at work, you're sitting at a desk, or you're working, whatever, you're working at your job and you're busy and you have to be present, and you're focused, right? And your friend just took a trip to, the Grand Canyon, right? And they are just they're in awe. They cannot imagine that something like this could ever exist on Earth. Something so giant, something so much bigger than themselves. And it makes them feel like a small person, like a small entity in a much bigger universe. But it also, at the same time, makes them feel connected to the universe, right? That the same forces that sculpted this Grand Canyon were involved in sculpting human biology, right? They experience all of these huge feelings that humans are capable of, and they want to transmit that to you. They want you to experience that, even though you're thousands of miles away. So imagine some scenarios, right? You're sitting at your desk. Let's say you sit at a desk, and you get just a sensation that somebody wants to interact with you. You don't know who it is necessarily, but somebody wants to interact with you. Sort of like you get that sense when somebody's looking at you, right? And you don't know that, you can't see them, but you just go to sort of get a feeling. I could imagine it being sort of like that, just an intuition. And then you explore that, you recognize that is occurring, and then you make the decision, okay, I want to know who it is, and it's your friend over in the Grand Canyon, and they're offering to you the opportunity to literally see what they're seeing. Okay, and so one could imagine, again, this is like the most sophisticated version of Neuralink. One could imagine that a component of your field of vision is now devoted to exactly what they're seeing in real time, what their eyes are seeing, right? And so you can see it, you're just seeing it, right? It's not like it's disrupting what you're doing, but you can just sort of, you get the experience of seeing it, right? I'm doing this, I wouldn't imagine it being like a picture-in-picture type of situation. It would just be like, you can just sort of get the experience a little bit, right? Just a taste of it. And then you decide, okay, wait, you sit back and you're like, I want to go to the Grand Canyon right now. And your friend permits you complete access to their sensory systems. And so now everything that they're seeing, they're hearing, they're feeling, they're emotionally experiencing is now occurring in you. And you just taste that for taste it. It's probably the only one that's not influenced would be taste, unless they're like licking the Grand Canyon. But anyways, you just get a sort of dose of that. And then you go back, and then you're back at work. You say thank you, and then you go back to work. And so Now, imagine this, right? Like, why does there need to be somebody there in that moment? One could imagine that you could just download the experience of going to the Grand Canyon, of walking around, of riding a donkey up and down the Grand Canyon. You know, it doesn't need to be a human there. Somebody just recorded all of the neuronal activity that would need to occur in those moments for you to experience that, right? So, you know, you just go to the library, sort of like you go to, you know, a library of video games or a library of books, and you just pick one out. That, you know, there's no reason you couldn't do that. Again, the most sophisticated version of Neuralink. However, what becomes interesting is that, like any computer system, theoretically it could be hacked, right? And so if this is a true whole brain computer interface, that means that Neuralink interfaces with not only your perceptual, your sensory systems, your memory, your thoughts, your all of that, but also your movement, right? The brain controls when, you know, my decision to pick up this pen, my brain has controlled that, right? Without a brain, that would not have happened. And so one could imagine that, okay, you know, I am imagine that I'm a terrorist organization, right? And I want somebody to blow up, you know, I don't know if I should actually say this out loud if I'll get in trouble, but I want somebody to blow up one of the buildings behind me, right? Which I do not, but okay. And I noticed that, there's like 6 people with Neuralinks in the area nearby, and I could just deposit, you know, a bomb or whatever, a bioweapon or something, somewhere in the city, and then I just hijack their movement, and now they are just a passive observer, right? Their sensory systems are still their own. In fact, you'll need them to have their sensory systems so that they can successfully interact with their environment. But they're no longer capable of, you've completely taken over certain regions of their brain that are devoted to controlling movement. So now they have no ability to control their movement. They are just observing, right? They can't speak, they can't move their lips, they can't make facial expressions. You can make their facial expression whatever you want. You can make like, right? Oh, this person's super happy. I doubt they're a terrorist. And then you just control them like a remote control car, and then take out, you know, do the act of terrorism. But it gets way worse than that. I mean, that sounds nightmarish, right? But it gets way worse than that, because if you can control that, if you can control any part of the brain, then what would prevent you from controlling what their desires are, right? If you could, you know, desire emerges from the brain, happiness, sadness, anger, hate, you know, love, all emerge in the brain, and therefore those would be under the purview of Neuralink, right? And so you could make it so that you're not controlling the person like a remote control car. You can make it so that, just one example, that they have an orgasm every single time they commit an act of violence, right? Orgasms are a strong motivator for a lot of people, right? For reproduction, notably. That is the evolutionary solution to motivate humans to engage in all kinds of irrational behavior that's not necessarily in their best interest, but promotes reproduction. Or even worse than that, you could make it so that they now, all of a sudden, today, believe that they want to commit this act of violence. And they get tremendous satisfaction. They have no prior exposure to that. They're not part of this organization. They do not want it to happen. But in a moment, now they believe that they have always wanted to do this, that it's the right thing to do, that it's justice, and that it's necessary, and so they go and do it. And they never knew at any moment that this was a foreign source of motivation that was planted. And so they're willful participants, but there's just no way for them to have known that they wouldn't have any reason to be skeptical. So that was a long, I know, sort of story in response to that topic. But yes, theoretically, now of course one would imagine, like any other computer system, they would have security measures, you know, and you know, strategies to prevent that from happening. But theoretically it's possible. If Neuralink is possible, if like that whole brain computer interface thing is possible, therefore all of those things would also inevitably be possible. So, which I know is probably like sounds a little alarming. Okay. Where does the intuition come from? No buildings were harmed in the scope. Indeed. Yes. And so DC Hooper headed out. Okay. You should all check out DC Hooper. She's awesome. Uh-oh. What just happened? Oh, no. That is a perfect... Oh, wait. No. Are we still live? I can't tell. I think we are. Okay. Okay. you know what? Okay. So if you wanted to stay in touch, we can't put security measures into things we don't understand and conceptualize fully. Indeed, but you seem to keep in mind this is a science fiction. In this moment, it's science fiction, right? We're just pretending like this exists. We're just pretending like this whole brain computer interface exists. There are scientists who believe that it will never exist, but yeah, ephemeral vicarious experiences. I love that. Yeah, totally. Not a set of words that I would imagine would come from somebody with the side boob in their handle, but I love it. And I love that you have that handle. But anyways, I should probably just close and say thank you so much for some of the most interesting experiences I've had over the past 5 years, many years. If you want to stay in touch, there's the last time I'll bug you about it. I have a YouTube channel, youtube.com/anthropoid, and I talk about specific topics like Neuralink. Actually, I just talked about it the other day on YouTube, but also Parkinson's, addiction, dreams, various drugs, hallucinations, all these types of things, COVID-19. And so youtube.com/anthropoid, or I have a link in my profile. And then also a new live streaming platform called haps.tv. I have a link to I have a link to that platform in my profile as well. It's a great community. It's still small, but it's a great community, and I hope you'll check it out. And so we can stay in touch, because once again, I just thank you so much for some of the most interesting times over the past 5 years. And I'm sad. It's rough. I was sad yesterday. I knew this was going to happen. We all knew this was going to happen eventually, right? But it's just, it's just been a really important. I mean, I've chatted with people for almost my entire PhD, the most important decade of my life. Chatted with people before and after I had a daughter, before and after I got married. By and large, the internet is a dangerous place, but by and large, this has been a wonderful, wonderful community for me. So with that, thank you, and I hope I will see you on other platforms. All right. Not gonna lie, got a little emotional there. Not allowed to make fun of me. I'm an adult man. Yeah, so thank you all for hanging out on YouTube. I really appreciate it. I love that the channel is slowly but surely growing, and it's a wonderful excuse for me to get to learn about new things that I wouldn't have learned otherwise. And so I really appreciate you joining me here at this early stage. And I hope you'll give me input. I hope you'll correct me when I get things wrong, and teach me the things that I don't know, and just give me input how I can do better, and we'll keep the conversation going. All right, until next week, see you guys.